Welcome back to Neural Intel. We're jumping headfirst into open language models.
Oh, yeah, those are hot right now.
They really are. And you sent us this really cool report on OLMo 2
OLMo 2.
from AI2, the Allen Institute for Artificial Intelligence.
Yes.
And so we want to sort of unpack that report. What are the technical advancements in this release, and what makes it so interesting? So you're looking for a good, thorough understanding of all the technical details and the performance benchmarks, and that's exactly what we aim to do here. So
Well, it's really quite fascinating to watch the open language model ecosystem develop. I mean, thinking back to the first OLMo release.
yeah,
In February of 2024, there's a clear trend in your materials. There's increasing participation.
right.
And also a real closing of the performance gap, between these open models and the proprietary models.
Right.
We've seen some really exciting contributions from projects like, LM 360's Amber, MAP's Neo models,
Yeah.
DCLM's baseline models.
Right. So really seeing a real blossoming of this space.
That's right. That's right. And what's really noteworthy is AI2's commitment to fully open science.
Yes.
I mean, they don't just share the weights, they show the training data, the code, recipes, intermediate checkpoints, and instruction-tuned models. And this all culminated in OLMo,
Right.
which was the first fully open mixture of experts model to really reach the Pareto frontier, both in terms of performance and size.
Okay, so it sounds like it's not just about more open models existing, but about them getting really good.
That's right. That's right.
And AI2 is really driving that, not just releasing models, but the whole set of tools.
The whole 9 yards, yeah.
So that leads us to OLMo 2, this new family of models.
Right.
What are the essential technical specs about OLMo 2?
Well, there are two models, a 7 billion parameter version and a 13 billion parameter version.
Okay.
What's really amazing is the training data. They were trained on up to 5 trillion tokens. And the report says that the performance, meets or exceeds that of other fully open models of comparable size.
Right.
They also have competitive performance with some open weight models like Llama 3.1 on standard, English academic benchmarks.
Right.
So to achieve this level of performance with fully open models is a real step forward.
5 trillion tokens.
Yeah.
That's a huge amount of data.
It is. It is.
So what were the key areas that allowed AI2 to reach this performance?
Well, they focused on 4 core areas, the first of which is training stability.
Okay.
Training these huge models for long periods is challenging.
Yes.
You often run into instabilities and loss spikes.
Right.
And the report emphasizes that these issues can really harm the performance of the final model.
Oh, interesting.
So although the actual techniques, they're going to be detailed in an upcoming technical report.
Okay.
AI2's focus on training stability was clearly critical to the success of OLMo 2.
So it's not just about avoiding crashes. It's about scaling efficiently
That's right.
and unlocking even larger models.
That's right.
So instability has been this hidden bottleneck.
Right.
And this is a huge step forward.
Absolutely. Absolutely.
What was the second area they focused on?
The second area is their approach to staged training and interventions during late pre-training.
Okay.
Pre-training these massive models takes a lot of time and computing power.
Right.
So if you discover some weakness or gap in the model's knowledge late in the game, you can't just restart from scratch.
Yeah, I see what you mean.
So AI2 explored interventions that you can apply towards the end of pre-training to patch these issues.
Uh-huh.
So they specifically mention learning rate annealing and data curriculum as techniques that they use to refine model capabilities as training was winding down.
So strategic adjustments in the learning process.
Right.
Very cool.
To optimize the outcome, yeah.
What about the third area?
The third area is their use of state-of-the-art post-training recipes. And they really built on the advancements they made with Tülu 3,
Right.
which is their suite of high-performing post-trained models.
Got it.
And they basically took the post-training methodology they developed for Tülu 3,
Right.
applied it directly to the base OLMo 2 models to create these instruction-tuned variants.
Okay.
And these are known as the OLMo 2 Instruct models.
Got it.
And they specifically highlight the 13 billion parameter Instruct model as their most capable OLMo 2 model.
Okay, and this is available in the AI2 playground.
That's right. That's right.
And what about that fourth area?
Right. The fourth core area was their actionable evaluation framework, which they call OLMES.
OLMES. Okay.
Yeah. AI2 set clear performance goals, and they analyzed how performance scaled with model size.
Okay.
And OLMES itself is a curated suite of 20 benchmarks designed to assess core capabilities like knowledge recall, common sense reasoning, general reasoning, and mathematical problem solving.
So not just more benchmarks, but good ones.
That's right. That's right. The idea behind OLMES was to create benchmarks that would give a strong signal even for small-scale experiments.
Right. That makes sense.
So it's a more targeted approach.
It is.
Uh,
What about this distinction between development and unseen sets of benchmarks?
Right. So the development set that included things like ARC Challenge, HeliSwag, MMLU. Those benchmarks were used to actually monitor and guide the development of OLMo 2.
Okay.
And the unseen set that was held back and included things like AG Evil, MMLU Pro, GSM 8K, they only evaluate on those after the main development was done.
I see. So that's to make sure they're not overfitting.
Exactly, exactly. It gives a more reliable measure of how well the model generalizes to new tasks.
Okay. So how did OLMo 2 perform on these benchmarks compared to other open models?
Well, the report has a detailed performance comparison across OLMES, and they categorize the baselines into three groups.
Yeah.
Open weight models, where usually just the final checkpoint is released with very little information about the training process. Partially open models, where the weights and most of the details about the training data are known.
Okay.
And then fully open models, where everything, the weights, the data, the code, the evaluation methodology, it's all out there in the open, totally reproducible.
Right.
And the main takeaway was that both the 7B and the 13B OLMo 2 models, those were the best performing fully open models to date.
Wow.
And actually, they often outperformed open weight models of a similar size.
That's huge.
It really is. It really is.
Outperforming while being totally transparent.
Exactly.
Any specific highlights about the performance?
So the report highlights a huge improvement over the previous model, OLMo 0424.
Okay.
Specifically, OLMo 27B outperforms Llama 3.18B,
Okay.
and the 13B OLMo 2 model outperforms Quen 2.57B.
Wow.
And that's despite having fewer total FLOPs.
So better performance with less compute.
That's right. It's about training efficiency.
Right, right.
And when you look at the Pareto frontier, the OLMo 2 models really stand out. They show a great balance between computational cost and performance.
So they're getting more out of the data.
That's exactly right, yeah.
Did those gains on the development set carry over to the unseen set?
Well, encouragingly, yes, largely they did.
Okay.
Although they do point out the limitation that there's no way to be totally sure that some of the tasks they considered unseen weren't part of the training data for other models.
Yeah, that's fair.
But they really emphasize that it's important to keep a set of tasks as truly unseen during development.
Right.
And they encourage other developers to be upfront about which tasks they use during development.
So again, more transparency.
Absolutely, absolutely.
Okay, so let's dig into the technical details here. What were the key architectural modifications and the pre-training process?
So the core architecture of OLMo 2 is similar to the original OLMo,
Okay.
but it includes some key changes to improve training stability.
Okay.
So they switched from non-parametric layer norm to RMS norm,
Okay.
reordered the layer norm, adopted QK norm,
Mm.
replaced absolute positional embeddings with rotary positional embeddings,
Okay.
and also implemented Z-loss regularization and an improved initialization.
Okay.
So I'll just give you a little bit of intuition for example, RMS norm and rotary positional embeddings.
Okay, yeah, break it down for us.
So, RMS norm, it simplifies the normalization process.
Okay.
It makes training more robust, less prone to numerical issues, especially during those long runs.
Right.
And as for the rotary positional embeddings, instead of giving each word a fixed position in the sentence, we can imagine that it gives the word a sense of where it is in the sentence by how it rotates its understanding of the words around it.
Okay.
So this helps the model understand relationships between words, regardless of the length of the sentence.
Okay, so a lot of intricate technical adjustments.
Absolutely, yeah.
What about the pre-training process?
Right. So they used a two-stage approach with a curriculum.
Okay.
And the first stage accounted for over 90% of the total pre-training compute. And for this stage, they used OLMo Mix 1124.
OLMo Mix 1124, yeah.
Which is a massive data set of about 3.9 trillion tokens,
Why?
taken from a bunch of different data sets like DCLM, DOLMA, StarCoder, and ProofPile 2.
Okay.
And OLMo 270 was trained for about 1 epoch on this data set, while the 13B model was trained for 1.2 epochs, up to 5 trillion tokens.
So first stage, just building that strong general understanding of language
Exactly, yeah.
with
Yeah.
this huge data set.
Right. And then the second stage, you're refining those capabilities
Right.
with more specialized data.
Absolutely.
Okay, so that first stage is pretty big.
It is, yeah.
What about the second stage of pre-training?
So the second stage used a smaller but more carefully curated data set called OLMo Mix 1124.
Llama mix, okay.
Yeah. Which has 843 billion tokens.
Okay.
And this data set came from two sources. One is high-quality web data that was heavily filtered,
Okay.
and then also some domain-specific high-quality data.
Yeah. Including academic content, Q&A forums, instruction data sets, and both synthetically generated and human-authored math workbooks.
Got it.
So from the second stage data, they created 3 different mixes of 50 billion, 100 billion, and 300 billion tokens each.
Great.
And each of these had 50% data from each of those 2 categories.
Got it.
So for the 7B model, they trained 3 separate copies of the model, all starting from the final checkpoint of that first stage. Each of these was trained on the 50 billion token mix, but the data was presented in a different random order.
Okay.
And then they used learning rate annealing and something called model souping.
Model souping. Interesting.
Yeah, to merge those models into the final 7B base checkpoint.
Okay, so like blending different versions
Exactly.
to get a more robust model.
That's right.
Yeah.
Okay. And then for the 13B model, they did something similar.
Okay.
They trained 3 models on the 100 billion token mix and 1 on the 300 billion token mix. And then they merged those into the final 13B base checkpoint.
So these instruct versions of the model,
Right.
how do they create those?
So for that, they leveraged the recent work with Tülu 3,
Okay.
which really pushed the state-of-the-art for fully open post-training methodologies.
Right.
And they applied the best recipe from Tülu 3,
Okay.
which combined supervised fine-tuning, preference tuning, and reinforcement learning with verifiable rewards.
Okay.
And then these instruction-tuned versions were evaluated using the Tülu 3 evaluation suite within OLMES, focusing on instruction following, knowledge recall, and reasoning capabilities.
Right. And how did those instruct versions perform against other instruction-tuned models?
So they were really competitive with the top open-weight instruction-tuned models.
Okay.
And actually, the OLMo 213B instruct model outperformed a number of models: Quen 2.5 14B instruct, Tülu 3 8B, and Llama 3.1 8B instruct.
Wow.
So it really shows that the strong foundation from the pre-training combined with these effective post-training techniques, it really pays off.
Leads to great instruction following capabilities.
It's pretty cool that they can just take that Tülu 3 recipe
Yeah,
and use it.
it is. It is.
Were there any adjustments made during post-training?
Yeah, they had to make a few adjustments.
Okay.
For example, they removed certain models from their completion pool to ensure that there were no restrictions on the use of the OLMo 2 outputs for creating derivative models.
Right.
They also updated the preference data to include on-policy completions generated by the OLMo 2 models.
Okay.
But the main thing is that the core SFT mix, the preference tuning process, those remained largely the same. The main differences were in the learning rates.
Right.
But they did see consistent improvements from using reinforcement learning with verifiable rewards in the final stage,
Okay.
especially on reasoning tasks like GSM-8K and math.
Right. So for people who are interested in this, what's available?
Well, they've released a ton of resources. There's a demo at playground.alani.org.
Okay.
The research paper is on RFEFT.
The base models, both 7B and 13B, are on Hugging Face.
Okay.
The names are Alani OLMo 2, 1124, 7B, and then 13B.
Got it.
The instruction-tuned versions are also on Hugging Face.
Okay.
Those are OLMo 2, 1124, 7B instruct, and then the same for 13B.
Got it.
And they've also released the pre-training data sets. So the Stage 1 OLMo Mix 1124 and the Stage 2 Domino Mix 1124 are both on Hugging Face.
Okay.
And they've also released the post-training data set, the Tülu 3 SFT mix,
Yeah.
and the preference data for both models and the RLVR mix, all on Hugging Face.
Okay.
And finally, there's an OLMo 2 Hugging Face collection page, so you can find all these resources in one place.
So they're really serious about this whole open science thing.
Oh, yeah, absolutely. It's not just about showing you how they made the model.
Right.
It's about letting you use it yourself, understand every ingredient
Right.
that builds trust and accelerates progress.
It does. So we've explored AI2's OLMo OLMo 2 in detail.
We have.
Their focus on training stability, these interventions, rigorous
Yeah.
evaluation. It's amazing that they're hitting this level of performance, even exceeding some open-weight models on benchmarks.
Yeah, and doing it all in the open.
Exactly.
It's really quite remarkable.
So I guess this release is a huge opportunity
It is.
to engage with these cutting-edge open language models.
Right.
All those resources, the models, the data, the code, it's a lot to explore.
It is.
What do you think are the implications of these innovations, of having these powerful, transparent models available?
Well, I think that's something for everyone to ponder. What new avenues of research and innovation might be unlocked by having these models readily available?
That's a great question for our listeners. Make sure to check out those links, explore the report when it's out, maybe even experiment with the models on the playground or on Hugging Face.
And don't forget, this field is always changing. Staying up to date is key.
Absolutely. Join us next time on Neural Intel as we continue to break down the latest in AI and ML.
And be sure to visit our webpage for updates on the latest research. You'll find the link in the bio.
Thanks for listening.
See you next time.